Okay, let's have a look at this question. We have a square ABCD, and as the diagram showing here, we folding the side AB to the AC, and we have a point B become a point P. The P position here was the B before. I'm going to write this down. That was like B before. Okay, and then we need to finding the total area of square RPQA, which is this one, the green one here. And compared to the original square, what fraction is the green to the original square? A, B, C, D. So that's a question. So how do we do it? So if you want to find the area of RPQA, so we need to find the length of PQ, right? So how do we find the length of PQ? So what do we have here? We actually have this length of AP here, which is same as this length AP. So what is the length AP? Because the length AP is folded from the length of AB, right? So if we make the length of AB is like A, length of A, so AP is also equal to A, so the AP here is also equal to A. So then we can using Pythagoras to find the length of PQ. So if you make length PQ is X, then let's find what is the X is in terms of A. So let's start. So we have the A square is equals to X square plus X square since it's a square. So then we have A square is equal to 2X square. So X square just equals to A square on 2. So then the area of this AQPR, the square, it should be just equal to X squared, right? Which is equals to, sorry, this is X on 2. I wrote it wrong. I'm changing that X on 2 here. Yeah. So the area of the square will be equal to X squared, which is equal to A squared on 2. And the original area of the big square ABCD is equals to A squared. Then therefore the fractions of the green area to the total area would be equals to A squared on 2 over A squared. Over A squared, which same as A squared on 2 divided by A squared means times 1 over A squared, which equals to half. So that's the answer.